Hi, my name is John Mark Rimstead, and today we're going to be covering 4.1 functions of two variables, right? So we covered this a couple weeks ago during our last unit and our last section with our exam number 4. I really loved it. I was really bought in, really enjoyed the functions and the two variable aspects and how this really can relate and be part of daily life for me, possibly my future job. Awesome. All right, so let's get into it. First, let's do some introductions and definitions. A function of two variables is a function that is to each input is associated exactly one output. The inputs are ordered pairs, x, y. The outputs are real numbers. The domain of a function is the set of all possible inputs, ordered pairs. The range is the set of all possible outputs, real numbers. This function can be written as z equals fx, fxy. Functions of two variables can be described numerically, so a table of some sort, graphically on a graph, x and y axis, algebraically, or a formula, a function, or in English through a word problem. All right. Awesome. So let's get into it. Example 1, we have consider the function fxyzw equals negative 75x squared w minus 1 over z plus yz squared. So that's the function that we're working with right here, right? And it tells us to evaluate the function f0, 1, 2, 3. So to help me, what helps me personally is I color coded what correlates to what, right? So for x, I put that it correlates to 0. So I put red. For y, blue, 1. Z, pink, 2. W, purple, 3. Awesome. And then right here is going to write it all out. So f, evaluating at this function, you're just going to input everything, right? So for that x, you're going to put 0. And for that w, you're going to put 3, and then 2 for that z, 1 for the y, 2 for the z again, right? So 75 times 0 squared times 3. All right, so we know anything times 0 is 0, right? So all three numbers right here can just be totally wiped out, cancel. You can put 0 without even thinking about it. Awesome. Next, you have negative 1/2 plus 1 times 2 squared. 1 times 2 is 2. 2 squared is 4. So we have negative 1/2 plus 4 equals negative 1/2 plus 8 over 2, which equals 7 over 2. Now, where did we get the 8 over 2? Great question. So 4, whole number right here, that has an imaginary 1 under it. All right. So what we're going to do is find a common denominator, which in this case is 2, right? So what we're going to do is to get the denominator 2, we have to times it by 2, which means we got to times the numerator by 2 as well. So that's how we get 4 times 2 equals 8. 2 times 1 equals 2. Therefore, we can add across, but because it's a negative 1, what you're going to do is you're going to subtract 1 by 8, which gives you 7, which is how we ends up with 7 over 2. All right, that's the first example. All right, let's move on to the Cobb-Douglas equation. The Cobb-Douglas production function is a mathematical formula used in economics to describe the relationship between inputs, like labor and capital, and output, total production. It's commonly used to model how businesses or economies turn resources into goods or services. The Cobb-Douglas equation captures how efficient and balanced a production process is. For example, a factory might produce more goods if it hires more workers or invests in better machines. This function helps managers or economists, predict how changing inputs will affect production. Right, so this is one of my main driving forces why I was super engaged with this section, why I chose this section to teach it. It's because I see real life application with it. I see how it can be used in everyday businesses, on how we can make businesses, systems, economies just more efficient and overall more productive as well as more profitable. Which at the end of the day, that is always the goal. All right, so let's move to example 2. A small manufacturing company produces 2 models of a surfboard, a standard model and a competition model. You can see this in many things, like BMW, Mercedes. You can even see in Toyota, right? With Toyota Tacomas, you have a basic, you have a sport, and you have the TRD, which is the highest trim. Suppose the standard model X is produced at a variable cost of 210 each, and the X competition model Y is produced at a variable cost of 300 each. Additionally, the company has total fixed costs of 6,000 per month. Awesome. So we're going to go through A. Write an equation that models the monthly cost of the company. So what we're going to look here, we're looking for X. X is produced at a variable cost of $210 each. Awesome. So we're going to put 210X. Okay. Next, we're going to look for our Y. Y is produced at a variable cost of 300 each. Perfect. We're going to do 300Y. And then you have a total fixed cost of $6,000 per month. That is no matter what. At the end of the day, you got to pay $6,000. Perfect. So you're going to add that at the end as well, giving us 210X plus 300Y plus 6,000. Awesome. Now, this is the function. This is our equation that we're going to use to answer B and C. B, find C2010. C2010 equals 210 times 20. Now, where are we getting this 20? We're getting this 20 from right here because that is in the X module, right? So we're going to plug that in right there for that X. 20 times 10 plus 300 times 10. Awesome. All right, so 300Y. And again, where are we getting the 10 from? We're getting the 10 from right here. Oh, excuse me. I don't know if I said 10 on 20. I meant 20. So 210 times 20. All right, excuse me for that. 300Y, 310, because that 10 is in that Y module again, right? Plus the 6,000. Awesome. So what you're going to do is you're going to multiply these two, and you're going to add up all three numbers, which is going to give you $13,200. Next, same type of method. You're going to be finding you're finding C55, right? Which is the 50 is in the X spot, so we're going to put it in that X. The 5 is in that Y, we're going to put it in that Y. 210 times 50, 2 times 50, plus 300 times 5, plus 6,000 equals 18,000. All right, so again, really what you're doing, you want to be slow, you want to be controlled, you want to make sure that you're putting things in the right spots, right? I'd rather you be slow and controlled than be fast and accurate, right? Awesome. Next example, example number 3. A car factory uses labor and machines to build vehicles. The production function is Q equals 5 times L squared times K squared. So what do these numbers mean? All right. Q is the number of cars produced per day. L is number of workers. K is number of machines. All right. So this is what I'm saying. This can be incorporated in every single business. All right. So for example, I work at Chick-fil-A. If I want X amount of sandwiches produced in a day, it's going to make me an X amount of profit. I want to know how many workers do I got to get their rates, things like that, things of that nature, right? Awesome. So essentially, it's just seeing how we can maximize the most out of our production and labor and things of that nature to get the most productivity and profitability. The scenario. All right. The factory employs 10 workers and uses 15 machines. So what you're going to do is 10 workers. Where are the workers? That's L. So you can put that in right there. 15 machines, K equals machines. 15 right there. So 10 squared is 100. 15 squared is 225. 5 times 100 times 225. That's 112, 500. Awesome. Cars produced per day. Right there. So you're plug and playing. Plug in and play. Plug in and play. Plug in and play. Be slow, be controlled. Know what you're working with. Know your numbers. Know your where. Awesome. Now for this last problem, we have this table, right, which is giving us, days, miles. All right. But first, I just want to talk about real life application, right? You can use it to do rental car, airplane flights. You're trying to find where can I maximize my money, right? So below or above, the table shows values for FWK. Suppose you are renting a car and W is the amount of days and K is the number of miles. Use the table to evaluate F4 200, F2 300, and F1 400 and interpret what they mean, right? So what we're going to do right here, 4, 200, right here, 4, 200, find where they match. They match at 46, so it would be $46 that day, right? So if you interpret what that means, looking at all the other prices here, this is probably not the greatest deal, right? The greatest deal is right around here. Anyways, F2 300, same thing. We're going to find that W, find that 2 right here. Go across that 346. Perfect. That's how much it's going to cost you per day. And then F1 to 400 right here. F to the boom, $45 a day. Essentially, what you're doing is you're finding the W, finding the K. You're finding out where they match. That's all that you're doing, right? And you're looking across at the other days. Is this going to maximize my money? Yes or no? All right. Last, this is a great, great, great question. Suppose you rent the car for 3 days. So 3 days. Is K an increasing or decreasing function of miles? Okay. So 48 for the first day, 56 for the next day, 66 for the next day, 84 for the next day. So throughout these 4 days, or these 4 intervals of miles or whatever, it is increasing function of miles as well as an increasing function of price. So it's getting more expensive the more you drive. So yeah, perfect. And that will wrap it up today. Thank you guys for staying along and paying attention. I really appreciate it. I had a great semester, and I appreciate you, Professor Wu, for all the help that you gave me and my classmates. You would definitely be getting a high mark on the Rate My Professor. Hope you have a great summer. Thank you.